Hi, so we're going to do Lab 10, the video for that, and I'm just going to flip this camera around. The purpose of our alcohol dehydration was to understand how elimination reactions occur, and this specific lab was an E1 reaction, and I think it's just a good opportunity for us to see the practical side of this mechanism versus just writing it on paper. So that was nice that we got to see that, and that Dr. Manrique did that for us because we don't really have a lab to work in. And here's my worksheet. Our mass of our crude product was 1.96 grams, and then the mass of our final product was 1.5 grams. And we used distillation, a separatory funnel, and then we also used a salt as a drying agent to get that final product and separate that product how we wanted it to. We could tell the organic layer was on top which was our pentene. You could tell that was on top. Just an easy way of figuring that out would be to add more water to your separatory funnel. Whichever layer got bigger was your water layer, and the other one was your organic layer. So an elimination reaction is just a reaction that loses a hydrogen and a halide on the alkyl halide chain, and this reaction produces a double bond, which is an unsaturated compound, or an alkene, and that's what we found. We had started with 2-pentanol, and our product was pentene. We use an acid to initiate the reaction. It pronates the hydroxide group of the alcohol to allow for water to then become the leaving group. So as soon as we can get rid of that leaving group, our reaction it's taking place, and we actually can end up with our product. So, and then I think the last thing is just these last mechanisms, basically, or I did both. So you can see we have a methyl group over here, and it's also, I guess, a methyl, but there's only 2 hydrogens because it's a double bond. And then with different reagents, which is over our arrow, what we use with our reactant, we got our product. So for example, we had our, there we go. That's what we started with. When we add hydrochloric acid, this double bond breaks. It actually takes that hydrogen and allows for that chlorine to then go back to that bond, and so our final product ends up being that. So that's just one example, but I've done these all and emailed those to you as pictures. Okay, bye.